Hello again. Welcome to another lesson in geometry. Today we are covering section 7.1, ratios and proportions. All right, so we have some vocabulary down below. Number one, write a ratio to compare 9 red marbles to 16 marbles in 3 different ways. So the one way is using the word 2 in between, so this would be 9 to 16. The other way is you can always write a ratio as a fraction, so this is 9 over 16. Remember, a ratio is a comparison of two numbers by division. And then we can put the colon in between, so this is 9 to 16. All 3 ways we say the same thing, 9 to 16. Okay? All right, so in simplest form, that means we have to reduce those fractions, because remember, we're just comparing two numbers by division. Okay, we want to write the ratio of the vowels to the consonants. Okay, so the vowels are A, E, I, O, U. So in this case, there's 1, 2, 3, 4 vowels, and 1, 2, 3, 4, 5, 6 consonants. So if we reduce that, there's our ratio, 2 to 3. All right, so for geometry, we have 2, 3, 3 vowels, and 1, 2, 3, 4, 5 consonants. So you could write this 3 to 5. Although maybe you would say that Y is sometimes a vowel and might be a vowel in this case, in which case you would say this is 2, 3, 4, 4 to 4, or 1 to 1. Okay, so depending upon whether you consider Y to be a vowel in this case. All right, ratio, that's 3 vowels to 2 consonants. And it's okay to have an improper fraction for a ratio. All right, so cross out the ratio that is not equivalent to 12 to 8. So in other words, which one of these would not be the same fraction as 12 over 8 or have the same value? All right, let's see. So if I was to double 6, it would become 12. But if I would double 2, it would become 4. So this is the one that's bad. But we can make that one work. This one here reduces to 3 halves, 3 to 2. And so does 12 to 8. That's the same as 3 to 2. Let's see, 8 divides into these evenly, so that's 3 to 2. And let's see, 12 is the biggest thing that divides, oh, nope. 16 is the biggest thing that divides evenly, so that goes in there 3 times and 2 times. So all the rest have the same equivalent ratio. Okay. Proportion. A proportion is an equation stating that two ratios are equal to each other. So for example, all these ratios up here were all equal to each other. So we could say this, 2/3 is the same as 8/12. If we reduce 8/12, we get 2/3. And 1/2 is the same as 5/10, because if we reduce 5/10, we get 1/2. Okay. So write 3 or 6 to make each proportion true for number 6 here. So 2/3, let's see, to make 3 become 9 down here, they times by 3. So 2 times 3 up top would give us 6. This was times by 2 to get to 8, or divide by 2 to get backwards to 4. So that means I go backwards, I get 3/4. Those two ratios are equivalent to each other. And 1/3 would be the same as 2/6. Those two ratios are equivalent to each other. And 5/3 is the same as 10/6. Those two ratios are equivalent to each other. All right, underline the correct word to complete each sentence. Distance on a map is proportional to the actual size. So if we do our map distance divided by the actual distance, we keep getting the same number over and over again. Okay, so that means they're proportional. The number of ounces in 3 pounds is in proportion to the number of ounces in 1 pound. Okay, on our second page here, we have a key concept, the properties of proportions. So the first one is the most important one, the cross products property, and this is how you solve for proportion when there's parts missing in Algebra 1. Okay, so if the proportion is A over B equals C over D, and the two bottoms are not 0, then we could do the cross products here. So A times D, okay, which is called the extremes for some reason, is equal to B times C, which are the means. So the means and the extremes are equal to each other. Okay, so AD is the same as B times C. So you learn this as cross products when you're in Algebra 1. And this still just says AD is equal to BC. We don't need to put the dots in there. So equivalent forms of a proportion. Proportion property number 1, if A over B is equal to C over D, that's the same as B over A equals D over C. So let's check our cross products just to show that they're the same. So here we would have done AD for the extremes. and the means this time are AD. So we're still going to get the same side, okay? And the same with the BC. So this is BC and BC. So our cross products are equivalent. So it doesn't matter where you put them. Sometimes you want to compare A to B first, or sometimes you want to compare B to A, so you can flip them upside down. It doesn't make a difference. All right. Property 2, AB is equal to CD, so that's equivalent as AC is equals B over D. Okay. So in this case, the extremes are AD and still AD. And then this one's BC and this one's CB, but when we're done, we still get the same thing. So it's saying you can switch the top right corner with the bottom left corner, okay? So these two you've probably used before when you're solving word problems with proportions. And depending upon the way your teacher taught you, they might have always used that way or maybe this way, okay? All right, so our last one, property 3. A over B equals C over D, and that's equivalent to A plus B over B is equal to C plus D over D. Now let's think about that one for a second, because that one's a bit different and you probably haven't seen it before. So let's simplify this. This simplifies to A over B plus B over B. And the same with the other side. This simplifies to C over D plus D over D. All right, so you can see your proportion in here. This is just 1. So this is A over B plus 1 equals C over D plus 1, because D divided by D is just 1. And then we could subtract 1 from both sides, and we get A over B equals C over D, which is exactly what we started with, okay? So if you do a little math in there, some algebra, you can prove that those are the same, all right? All right, so identify the means and the extremes in the proportion 2 over 3 equals 4 over x. So the means are the 3 and the 4, and the extremes are the 2 and the x. Okay, so the top left times the bottom right are the extremes, and the bottom left times the top right are the means. All right, so identify the property of proportions if each statement illustrates. All right, so let's erase a little bit above here so that we can see it better. I'm going to erase this part so we can look at these 3 properties here. All right, so in our properties, let's see, so we have 3 over 12 equals 1 over 4, and then that says that 3 over 1 equals 12 over 4. All right, so which one is that? All right, so they switched these two, okay, the means together, okay? And that was property number 2. All right. Number 11, 4 over 5 equals 8 over 10, then 4 times 10 equals 5 times 8. So this is our cross products property, this top one. All right, so 1 over 3 equals 3 over 9, then 3 over 1 equals 9 over 3. So this is just flipping the proportion upside down on both sides. So the ratio 1/3 flipped to 3 over 1, and the ratio 3/9 flipped to 9/3. So this is property 1. All right, so then probably the last one here is going to be property 3, but let's see how it worked. So we have 3/4 equals x over y, so the ratio of 3 over 4 to x over y. And then we change that to 7 over 4 to x plus y over y. So here on this side, they took the top number and the bottom number, add them together, and still put it over the bottom. That's just what they did in property 3. And this one, they simplified it a little bit, but what they really did was the top became the top plus the bottom, still over the bottom. And then they added the 3 and 4 to get 7. So this is property number 3. Okay. All right, down below we have a problem here. So writing a ratio. A bonsai tree is 18 inches wide and stands 2 feet tall. Okay. What is the ratio of the width of the bonsai to its height? So the bonsai is 18 inches wide and 24 inches tall. And that's because it was 2 feet, but we need to make it the same units, so 24 inches. All right, so write the same ratio 3 different ways. So we're going to use it with words. And we're probably going to want to simplify this. So 18 over 24. Let's see. So 3 divides evenly into both, but so does 6. And 6 is bigger. So the 6 will make 3 on top and 4 on the bottom. So I'm going to do a ratio of 3 to 4. Or 3 to 4 as a fraction. or 3 to 4 using the colon. Okay. All right, so the width of the bonsai to the height of the bonsai. Okay, problem number 3 is kind of a classic problem here. So the lengths of the sides of a triangle are an extended ratio 4, 7, 9. So that's, we don't know exactly the lengths, but we know they come in the ratio of 4, 7, 9, and they say extended ratio because there's some number that we can times to all these to make their actual lengths. Okay. All right, so the perimeter is 60. What are the lengths of the sides? So label the triangle at the right and use the extended ratio to write an expression for each side length. So one of them is done for us. So the extended ratio was 4 times x. We don't know the actual constant we're going to times to, so we let an x be there. And then we're going to have 7x and 9x, but we do know the actual perimeter is 60. Okay. All right, so complete the model to write an equation. So the sum of the lengths of the sides is, of course, the perimeter. So if you add up all 3 sides of the triangle, you get the perimeter. So this is going to be 4x plus 7x plus 9x equals 60. And then we're going to solve for x. So 4x plus 7x plus 9x equals 60. Combine all their x's and we get 20x equals 60. So we would divide both sides by 20 and find out that x is 3. All right, so then we can plug that constant in to show how big the actual sides are. So 4 times 3 for our first side would be 12 long. And then 7x times 7 times 3, plug in 3 for x, will give us 21 long. And then in our last one, we have 9x, which is 9 times 3 for 27 long. Okay, so the constant that I was going to times to all these was 3. So 4 times 3 is 12, 7 times 3 is 21, and 9 times 3 is 27. And if you add up all those extended ones, now you get 60, which is what the perimeter is supposed to be. So the lengths of the sides are 12 centimeters, 21 centimeters, and 27 centimeters. All right, problem number 4, solving a proportion. So write a solution to the proportion of 9 over 2 equals a over 14 and justify each statement below. So the first one was just, this was our given, or we just write the proportion down. Okay, so copy it out of the book here. And then we're going to do our cross products, 9 times 14 for the extremes, 2 times a for the means. So this is the cross product property. Okay. And then we're just going to multiply 9 times 14 together to get 126. And then I'm going to divide by 2 to both sides. So this is the division property of equality. You can always divide something to both sides of an equation. And then when we're done, we're just simplifying that 126 over 2 to get to here. Okay, problem number 5, writing equivalent proportions. So use the proportion x over 6 equals y over 7. What ratio completes the equivalent proportion 6 over x equals something? Okay, so we're going to fill in the something. So what did they do to the left side? It was x over 6 and now it's 6 over x. We're going to figure out how does that change our right side. All right, so use the diagram at the right and draw arrows from the x and the 6 in the original proportion to the x and the 6 in the new proportion. So x went downstairs and 6 went upstairs. Okay, circle the equivalent proportion that shows you what you could use here. So it was a over b, but now it's b over a. So that's going to be this one here. Okay. So complete x over 6 is y over 7 is equivalent to 6 over x is the same as, well, if I flip one, I have to flip the other, so 7 over y. And that's what's happening in the original form, our property here. We flip the first one, a over b turns to b over a, so we flip the second one, c over d becomes d over c. All right. Lastly, we have a lesson check here. So as always, pause the video first, do the lesson check, and then come back and check it over. All right, welcome back. So what is the error in the solution of the proportion at the right? Circle the, well, let's take a look at it first. So they do a cross product property here. So that should have been 7 times x, and then the means would have been 3 times 4. But that is definitely not what happened here. All right. So circle the means of the proportion and then underline the extremes. The means should have been 3 times 4. And the extreme should have been 7 times x. Okay? Write what each product is. The mean should have been 3 times 4, which is 12, and the extreme should have been 7 times x, which is 7x. What is the error in the solution of the proportion here? So the cross products were not done correctly. Was not done correctly. Okay, and now we'll solve it correctly. All right, so we had 7 over 3 equals 4 over x. Cross multiply. We have 7x equals 12. Divide both sides by 7. And x is going to be 12 sevenths is fine. Okay, you can make it a mixed number, or you can find the repeating part in that decimal if you feel like it. All right, so check off the vocabulary words you understand. Proportion, I hope you got that down in Algebra 1. Means and extremes are probably new words for you, but they're not hard. Just remember the extremes is the top left times the bottom right when in your cross product. And the cross product property, I'm sure you've used a lot. Okay, so hopefully you're already over here. If not, you really need to go back and do some review because we're going to use proportions throughout this whole lesson. All right, whole chapter. All right, see you in class next time.